guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have a pretty interesting problem that I'm very excited about, so let's go ahead and read the problem statement. So he says convert binary search tree to sorted doubly linked list, right? So he says to convert a binary search tree to a sorted circular doubly linked list, right, in place, okay? So he's saying you can think of the left and the right pointers, right, as synonymous to the predecessor and successor pointers in a doubly linked list, right? Pretty much he's saying for a circular doubly linked list, right, the predecessor of the first element is the last element, right? And he said, and the successor of the last element is the first element. All right. It says we want to do the transformation in place. After the transformation, right, the left pointer of the tree, right, the tree node should point to its predecessor, and the right pointer should be pointing to the successor, right? You should return the pointer to the smallest element of the linked list, right? Okay, that's interesting. So that's a very, very good question, man. I like it. So we're pretty much going to be given, pretty much what they're saying, guys, we're going to be given this binary search tree, right? Right, and then our job, right, is to pretty much return to them the doubly linked list, right? In sorted manner, right? So that's an interesting thing, right? So you guys can see, right, we're given this binary search tree, and you see the list that we end up returning, right, is 1, 2, 3, 4, 5, right? They're sorted. They have to be sorted, right? So we need to find a way, right? Because we're gonna be giving the root, right, as a reference, and then the tree, right, and then find a way to transform this into that, right? Pretty much changing the pointers, right? It's gonna be the same structure, right? We're just gonna be manipulating the pointers, guys, to make it look like that, right? And yeah, so that's kind of our job, right? You know what I'm saying, yeah, and they show the explanation how messy it looks right there. I'm saying, so yeah, pretty much they're showing you lines, and this is the successor, right, and this is the predecessor. So 1 points to its successor, right? Pretty much the node that comes after it, right? Which makes sense, right? And then the 2 points to its predecessor, right? The node that came before it, right? Which is 1. So that's why they all do, right? So all the nodes, right? Pretty much this is saying all the nodes, right, should be pointing to their predecessors. Or the left pointer, right, should be pointing to its predecessor, and the right pointer should be pointing to its successor, right? That's what they want the nodes to be like, right? So very, very interesting, right? So yeah, so how can we do that, guys? So pretty much, guys, the way we're gonna solve this problem is gonna be very intuitive, right? Because remember, we're given a binary search tree, guys, what I'm saying, and you guys know what that means pretty much, right? So the elements are pretty much are organized, right? So pretty much all the every node, right, when binary search tree, right, the left node, right, the left child is smaller than the root, right, and the right child is bigger than the root, right, or equal, however you want to organize it. Pretty much there's no duplicates, right? The left is smaller than the root, and then the right is bigger than the root, right? So saying that, right, we could easily, guys, what I'm saying, with that in mind, right, we know that when we do an in-order traversal of a binary search tree, right, we get the nodes, right, in a non-decreasing order, right? So that's a very good thing that we do, right? So that's what they told us, and pretty much we know how to traverse in order, right? So the nodes, right, when we do in-order traversal, we get the nodes, and we get them in non-decreasing order, right? Which is very important, right? Pretty much sorted, pretty much, right? I'm saying, so I'm being very clear about that, guys, because my last video I didn't really mention that, right? But doing the in-order traversal is going to yield us in having the nodes, right, in a non-decreasing order, right? One of my subscribers actually told me that to make it more clear, so you guys can understand why we do the in-order traversal when we want to get the nodes in order, guys. So that's why we do it, because we were given a binary search tree. So we're gonna be doing the in-order traversal, right, of the tree. So pretty much we're gonna visit 1, right, and then 2, 3, 4, 5, right? And as we're visiting them, guys, we're gonna be doing good things, right? So the trick is, right, we need to because they told us that, right? We need to return the pointer, right, to the smallest element, right? So pretty much the edge case that we're gonna take care of, right? We need to worry about that. We gonna be have some kind of head pointer, right? That pretty much gonna be pointing to the first element that we end up processing, right? Which is gonna be 1, right? Because 1 is the smallest element, right? Because we're gonna be doing the in-order traversal. Pretty much 4 is gonna call it left, right? In-order traversal again, right? It's left, root, and then the right? So we go left as much as possible, right? Then 1 is gonna be the first node that we end up processing. So the edge case to the head, right? The head pointer is gonna equal to that first element, right? And then and then we're gonna return that reference after we're done, right? And then the other thing that we're gonna take care of, guys, as we're traversing the nodes, right? We're gonna have to keep track of a previous node, right? In the traversal that we're doing. So we do that, guys, the previous node, right? Because we want to, once we add a particular node, right, we want to point to our predecessor, right? In the in-order traversal, right? We want to point to our predecessor, and having a reference to that, right, is going to help us to easily do that connection, right, to our previous node, right, that came in the previous thing that we're at, right? And that's how we're going to go about it, you know what I'm saying? And then the whole code is going to be very, very intuitive, guys. It's just as easy as that, right? And then we point to our previous node, right? And our previous node can point to the node that we're at right now, right? The root that we're at right now. So it's going to be very cool. So let's do it real quick. So pretty much 1, visit 1, right? 1 head points to 1, right? And then we done visiting 1, and then we go to 2, right? 2 points to 1, right? 1 points to 2, right? And then we do that at every node, guys. And just like that, we visit the right side, and then the previous node now is going to be 2, right? And then 3 could point to the previous node since we have reference to that, right? It points to 2, right? And then 2 points to 3, right? Just like that, guys. So let's go and implement it real quick, and then we'll go over the walkthrough real quick, so you guys can solidify the thought process. So pretty much the head, guys, I told you guys about, right? We're gonna have a head variable that's pretty much gonna help us, guys, and having a reference, right, to the smallest element, right? Because we want to return that to the caller because they want us to return it, right? And then we're gonna have the previous node, guys, pretty much helping us and keeping track of our predecessor, right? Which is very, very important, right? So pretty much, guys, we're gonna be passing in the root. So we're gonna be using a helper function to do the in-order traversal, right? After that, guys, we're gonna be returning the head, right? After we're done, right? So let's implement the helper function. So yeah, so we're now returning anything. So helper. So node root, right? Pass in the root. So we know the root is null. We return, right? We return from the call. Okay. So after we're done with that, guys, the next thing that we're end up doing, we're gonna visit. Yeah. So let me just call this in order, guys, so it's extremely clear for you guys. So in order traversal, right? So we're gonna pass in root that left, right? All right. And then we're gonna be doing in order the right side, right? And in between, guys, we're gonna be doing some magic, right? That's where the magic really happens, guys, right? So the next thing that we're gonna do, guys, we're pretty much gonna ask, right, is the previous, right? We are not processing node yet, right? So if the previous node is null, right, edge case, right, that pretty much means we haven't found it, we haven't visited a node yet, right? So pretty much we do head. That means that must be the first element, right? That's the case that we're 1, right? There's no previous node of 1, right? There's no predecessor of 1. So that the edge case we take care of, right, previous null, and then we point to that that node that we're at right now, which is 1, right? And then yeah, and then after we do that, guys, what we do, right, let's say prev is not null, right? That's all for all the other cases, right? We do prev that right should be pointing to the node that we're at right now, right? And then the node that we're at right now, right, the left one, right? So pre, right, is pointing to its successor, right? And then the node that I'm at right now, right, points to its predecessor, which is the previous variable, right? And then yeah, before we visit the right side, guys, we need to update the previous node to equal to that current root that we're at, so that in the next node that gets visited, right, you know, it can have access to its predecessor. It can easily do that connection right there, right? I'm saying, so if we didn't have that, there was no way we would have been able to connect our pointer to our previous node, right? That's why we need reference to that node, right? And then one important thing, right? It's a circular thing, right? Circular doubly linked list, right? So we need to do something, right? So the first node, right? The head node, right? The one, right? Should be pointing to the last one, right? So you guys can see the one, right? Is pointing to the last node, right? That's what I'm saying. The last node is pointing to the first one, right? So yeah. So the head that left, right? That's my address, right? It's gonna be pointing to the previous node, right? Because that's the last node that got visited, right? So I guess still got reference to it, right? And then the previous, right? Right. So 5, right, points to 1, right? Okay, so which is the head, pretty much, right? And after that, we just return the head, guys. So let's. I think the logic's pretty sound, so let's run the code, see if we didn't miss anything. All right. In order. All right. Let me just copy that. Maybe. All right. All right, cool. Seems like we passed everything. Let's press submit. Edge case. If it's my bad, then really, if root is null, right? Yes, a returned root, right? Or return null, doesn't matter. Good. Press submit again. Perfect, guys. We're able to pass all the test cases, guys. So let's go ahead and yeah. So pretty much how the whole thing works, guys. To recap, to do a quick walkthrough, right? We need to have reference, so we get the head, right, to pretty much point to the smallest element, right? In the previous node to pretty much helping us and having reference of the previous of our predecessors, pretty much, right? And then we do the in order traversal of the tree, right? So we visit, so we go left as much as possible, right? Boom, we go to 1, right? 1 previous null, right? Since we haven't visited a node yet, right? There's no predecessor yet. So the head is equal to root, right? The root now is 1, right? And then we're good. And then now we go to the right side, right? The right side is null, so we go back up to 2, right? After we're done, right? Go back up to 2. And then 2, right? The previous node, so 1, so before we went back up, right? Remember, we updated the previous node to equal to 1, right? So that at 2 is going to be able to point to, so right now when we get to previous, not null, right? When we're at 2, right? So that's where we end up, so previous not null, right? So now we go to this code, right? Prev, right? So now the previous node, right? That right pointer, right? Should be pointing to its right pointer, right? You see they're null right now, right? But now we're going to be pointing to the our successor, right? Which is 2, right? Point to 2. And then the 2, right? 2's left pointer, right? It's going to be pointing to the predecessor, right? Which is a prev, right? And then we do the same thing. Then the prev gets updated to 2, right? Before we visit the other nodes, right? And then we visit the right side. And the right side, right, the 3's left can point to 2, 2's right can point to 3, and then we do the prev gets updated to 3, right? And then we do the same thing, guys, just like, you know, prev 3 could point to 4, 4 could point to 3. That's the whole point, guys. So hopefully you guys everybody get it and you guys were able to understand the whole overall thought process. So if you guys like the video, make sure to give me a like. If you guys are new here, subscribe to the channel, guys. You know, and we have a lot of fun here. We enjoy ourselves. And yeah, guys, I want to thank you guys for taking the time to watch the video. And I'll see you guys in the next one.